In this video, we're going to look at a concept that's related to probability, or similar to probability, but it is a bit different, and that's the odds of an event occurring. And in this video, we're going to determine the odds for and against an event. The outcomes we're going to cover include explaining the difference between odds and probability, and determining the probability of an event given the odds for or against. So we're going to start once again with a definition. The odds are a ratio that compares the number of possible successful outcomes to the total number of possible unsuccessful outcomes. The outcomes that you want versus the outcomes that you don't want, which is a bit different than probability. What you'll notice with the odds is that the successful outcomes added to the unsuccessful outcomes is equal to the total outcomes. And we use total outcomes in probability. So we're going to look at a quick example here to try to differentiate between the two. If I want to roll a die and I want to roll a 5 on that die, we know that there are 6 faces on a regular die. Each one has a different number, 1, 2, 3, 4, 5, or 6. Well, the probability of rolling a 5 would be 1 in 6. There is one face, one way to roll a 5, out of the 6 faces total. But that means that I can also roll a 1, a 2, a 3, a 4, or a 6, which means that there are 5 ways to roll something other than a 5. So that means that odds for rolling a 5 would be one event that is successful, the roll of the 5, versus 5 rolls that are unsuccessful, or 1 to 5. So the odds of rolling a 5 is 1 to 5. The odds of rolling something other than a 5, or in other words, not rolling a 5 though, there are 5 ways to not roll a 5 on a die, and there's only one way to roll a 5 on a die. So the odds against rolling a 5 are 5 to 1. Okay, in this example, for the grand opening of our coffee shop, Maria is having a promotion. Each customer who makes a purchase gets a scratch and win card. Half of the cards are winners. Suppose a customer has 3 scratch and win cards. First question, what is the probability of all 3 cards being winners? And we're going to tackle this problem by drawing a tree diagram. Okay, and in my tree diagram, I'm going to use a little key here on the side. A W stands for a winning ticket, and a T stands for try again. Okay, so if there's a 1 in 2 chance of winning, that means that I have 2 possible outcomes the first time. I can either, on my first card, I can either win, or I can get a try again card. On my second card, I can get a win. So that means I could have won on my first one and won on my second one. Or I could have got a try again on my first and got a win on my second. Or I could have had a try again on my second card. And then my third card, once again, I could either win, which I'm going to include with all of my possible outcomes from my second trial, or I can try again. Okay, so in my tree diagram, it's called a tree diagram because each successive level appears to branch off from the previous level. I could have either win, 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 try again, win, try again, win, win, try again, and so on and so forth, which leads me to 8 possible outcomes. So here are the 8 different outcomes. Okay, so I have 8 outcomes. And I only have one outcome, which is the very first one, where I win all 3 times. Okay, so what does that mean? That means there are 8 total outcomes. One of them is successful, and that leads to the probability of 3 cards being winners being 1 out of 8. One successful outcome out of 8 total outcomes. So probability is 1 out of 8. But what are the odds of winning all 3 cards, on all 3 cards? Well, like we said, there is one successful outcome, and there are 8 total. So that means that there are 7 unsuccessful outcomes. So the odds for winning all 3 cards is only going to be 1 to 7. Okay, so to summarize, again, odds are the ratio of wanted outcomes to the unwanted outcomes. And if we add together our wanted outcomes to our unwanted outcomes, that'll give us the total outcomes that are possible in any example.